Hi, I'm Andrico, a web developer at Anima, and we recently released some really cool AI features that massively improve the code that we generate from your designs. And so we're going to be using this video to run through how you can use Anima and these brand new features to create a working two-player Pong game. And we're not just going to be using Anima, but a handful of different AI tools. So we're going to be using Dall-E to create the background image for our game. We're going to create the UI using Figma. We're then going to use Anima to generate the working React code from those designs in Figma, and then use some of the AI features to wire up some basic interactions. We're then going to finish off with GitHub Co-Pilot to just add in any missing interactions. So a little disclaimer before we start. Anima is a really cool tool for generating code from your designs. So you can generate working React projects, HTML, Vue, different CSS solutions like Tailwind, and TypeScript as well. And it does a lot more. But it's not a game engine. And so in this video, we're going to be pushing it a little bit past the limits of what its intended usage is. So if you're trying to create a game using Anima, just be wary that it's probably not going to be working as intended. And with that out of the way, let's start creating our background. So I've opened up ChatGPT here, which allows us to use the Dall-E tool, which creates images from prompts. And the image we're going to want is going to be the background for a video game. And so if we have let's kind of open up here, and let's kind of get an idea as to what the UI is going to look like. So we're going to have like a nice long rectangle here, and we're going to have one paddle on the left and one paddle on the right, plus a scoreboard at the top, and then like a ball that kind of like bounces off and everything as well. So the background that we want is going to be a kind of a long rectangle with a quite wide aspect ratio. It's going to be landscape. And so we're going to feed that information into Dall-E just to ensure that we get the right format. And so that's the kind of layout of the image that we're going to want. But what about the appearance? Well, we can do a handful of different things. We can have any style that you want. You can have like retro, you can have it hyper realistic, you can have it like scenery, be out of space. And so what we're going to do is a cool retro futuristic look. Maybe something that's been taken from like an SNES game that's set in, I don't know, like out of space or in the future. Because those are kind of just like aesthetics that I really like. So we're just going to be prompting that in to ChatGPT. So the first thing we're going to do is background for a video game. And we want a landscape with an aspect ratio of, let's say, 21:9, although it's not always perfect with coming up with the right dimensions, I found. Maybe I need to be more specific with the actual dimensions, but I think that should be fine enough. We definitely want it symmetrical because we've got two players, one on each side, and so we're going to want to make sure that it doesn't look too uneven. And then cool, about the style that we want, let's go ahead and say vaporwave aesthetic. And then we're going to maybe have like retro video game, like F-Zero. And this is because I've been playing F-Zero on the Switch recently, and I love it. It's so much fun. And I love the visual design as well. And just to kind of add like a feeling of a more competitive aspect, we'll have the color scheme on one side slightly different from the other side. So it kind of looks like you're entering two different territories when the ball kind of moves past the center. So let's say the left-hand side should emphasize the, let's say, red color scheme, and the right hand side should emphasize the blue color scheme. And hopefully this should work quite nicely. It usually takes about 30 seconds or so for Dall-E to create an image, and we can always tweak the prompt if it comes back in something that we're not too happy with. Okay, whoa, this is cool. I'm into this. Okay. So it's got the kind of futuristic aesthetic. I'm not sure if it's fully symmetrical. I have had issues in the past where it's not perfect, but hey, I think it's a good start, and I'm happy with this. So let's go ahead and download that. Cool. So the next step is to jump into Figma, and then we'll just go ahead and drag the image into like an empty project. And what we'll start with is take a look at the dimensions here. So we can see that actually what I'll do is I'll crop it ever so slightly, just so it feels a bit more symmetrical. Perfect, cool. And then next step is to just change the height, because I think this is going to be a little bit too big for our screen. Let's go ahead and change this over to 600. Let's zoom in a bit more. Okay, and now we're just going to need to wire up the user interface. So let's go ahead and make a frame here, and we'll just name our frames just because that tends to help with the AI tools that we use to generate code. So let's say a game, and let's call this background. And then I'm going to go ahead and maybe add a rectangle for the paddle. So we should have it like that. Maybe just give it a 40 and cool. And let's just do the same over here again. And what I'm going to do, let's just make sure that it's 40 pixels or so towards the edge, and we'll do the same here as well. Great, one more. Perfect. And we'll put it center. And we'll do the same here. I don't know all of the Figma shortcuts, so I'm sorry for all the Figma experts out here. I'm probably getting really annoyed at how slow I am. We'll also add some effects too, just to kind of make it pop off from the background a bit. I'm just going to make the shadow a little bit stark, and we'll give it some spread as well. So you can see, yeah, it sticks up a little bit more. So we'll do 0.444, 50%, and we'll do the same over here as well. So let's go 0.444 and then 50%. Nice, that'll stick up. And now let's use the Figma color tool to pick the color for our paddles. So we use red on the left-hand side and we use blue on the right-hand side. So let's go ahead and open this up, and I'm opening up the color tool up here, and we'll just go from pick this one. Nice, so that kind of fits in our color scheme a little bit, and we'll do the same for the blue as well. So let's open up the fill, and we'll pick like a bright blue. Nice. And so the next step is to create a cool circle. We'll give it let's do, I don't know, 48. Cool. And again, we'll give it a nice little shadow, just so it pops off the screen a little bit more. That looks good. A little bit too stark, maybe there. Actually, what I'll do is I will remove the white a bit. There we are. So it's split center. And finally, I'm going to give this a purple color, just so it kind of, again, fits in. But I will use the HSL tool to then just kind of tweak the hue a little bit. So hopefully that kind of fits in a little bit with our game, and we'll center that. And then, so I'm just going to go ahead and name this ball. We're going to name this paddle 2. I'm going to name this paddle 1, and background. And then finally, let's go ahead and add our scoreboard. So we've got a rectangle there, and I'm going to give it a black background, but give it a bit of an opacity. And then finally, let's add the score. And I actually have on my computer, we'll do text center line, a really cool retro gaming font. So we'll be using that, and we'll need to make it bigger. So let's go 70. Ah, that's perfect. Great stuff. Nice. So this is kind of our board game. And I'm going to go and just do that scoreboard over here, and then we'll call it score as well. This is kind of like the fundamentals of our game. Let's go ahead and turn this into working React code. So I'm going to go ahead and open up Anima. And if you haven't used it before, you're probably going to have to go into the Figma store and find the plugin, but you can just install it and then create a free account. And the free account should get you most of the way there for this video. I think a couple of things are locked behind pro users, but there is also like a free allowance for generating code. So that should help you get through through this video. So the first thing we're going to do is select the game. And you can see that we've got some React and CSS code, and I can go ahead and maybe choose Tailwind as well. And we generate the code, and you can see we've got our Tailwind classes, which are really cool. But we just, for this video, just interested in regular old CSS. And then let's open this up in a playground. And it's not going to work with all of the functionality just yet, but it is just going to get our code running just to see what it looks like, just to make sure that the appearance is fine, that the images are centered and all of this. It should be fine, but it normally takes just a few seconds. Cool, perfect. Let's go ahead and widen this out. So let's full screen it. And yeah, everything looks good. We've got our paddles and our ball, everything kind of in the center. So this would be like a good start for us to go on. You know, if we were making a site, this would be kind of like the foundational React project. But we want to do a little bit more than that. We want to actually create some fancy functionality. So I'm going to go ahead and toggle the AI mode on. And then I'm interested in setting this to smart mode as well. This uses a kind of a more advanced LLM. It's a little bit slower, but the output is generally a lot better and it can handle more kind of complex projects. This is a pro feature, but fast will be available to free users as well. So now you can see it's generating the code and it's kind of annotating it a bit more as well, which is really cool. And so this is what our AI settings look like. We can do a handful of things. We can pass through a little code snippet so that Anima kind of derives the code conventions that you use and then applies that to the code it generates for you. You can pass through a handful of presets, which are really just kind of like battle-tested prompts that we've kind of worked and tweaked ourselves to help improve the design based on what you'd like. So we've got a handful to use more CSS grid or Flexbox. And we've got this interesting one called Make It Work in quotes. And I'll kind of dive into that in a second. And then finally, you can kind of pass through your own prompts. So if you want to do something like maybe use arrow functions instead of function declarations, then you can run that through here. And then the Anima AI will kind of take that into consideration when it generates your code. So what's going on in this Make It Work? Because this is what we've got selected for the game. And really, this uses a handful of different prompts to just help get things started when creating a more interactive design. So I'm just going to make a text box here. And I'm just going to copy in some of the prompts, not all of them, but just the ones relevant to us here. And I'll kind of step through what they're doing. Cool. And I'll probably want to use a slightly better font family to display this. Okay. Yep, not the best. Let's go ahead and just do Avenir. Great. Oh, and there's a little bit of a typo here. Great stuff. So it's doing a few things. Let's move this out of the way. We'll reopen the plugin in a bit. So first off, we're asking it to make the web app work using best practices and add comments explaining what you're trying to accomplish with each step. The second one is particularly interesting because it uses a technique called chain of thought, which just asks, instead of asking the AI to just kind of give us the answer, to just annotate what it's doing as it goes along. And we recognize that this generally results in more accurate outputs from the AI. There are a few other things that we're adding, just kind of like catch-all, to add state management maybe for a file, but not for the entire app. Not really interested in that for now, so I'll just remove that. The other one is just to add some, this one here is for adding error handling for edge cases. And again, we're adding in some console logs here, simply just to kind of help the developer who's picking up the code kind of see what's going on and understanding what's happening. We are fine with a little bit of repetition. We don't want to have too many crazy abstractions or functions. So repetition is fine. We also find that using all caps and exclamation marks tends to work a little bit better. But I kind of feel bad shouting. But the logic is being added, and it's not just like a little comment asking the developer to kind of fill in the rest of the owl. And now here's like a weird little hack that we've kind of noticed, and we're probably going to make for a more elegant way of handling this. But yeah, if you have a frame like this with some text in it, and we'll make this a little bit smaller, we'll make it 20, and the text has like the rules for your games, then we generally recognize that the AI is really good at, or at least better at, generating the logic. So if I go ahead and make this left aligned, we'll give this like maybe 12. We don't need it that big. And just for appearance sake, actually should be fine like this. And I'm going to call this rules. Pong rules. And actually, I'm going to call this Pong as well. And then we can, once the code's been generated, we can just kind of delete these instructions. And so let's go ahead and now let's just regenerate everything. So the personalization code generation does take a little bit longer. It will take a few minutes. So I'm just going to pause the video and we're just going to jump back in when it's done. Okay, so here we can see the code that Anima has generated. And so let's just kind of have a little quick glance at what's going on. So you can see that it's got a bit more interactivity. It's created some state for the paddle positions, the score, the ball positions, and then the ball direction. So you can see it's got some handlers for key presses, updating the ball position, and then finally just kind of setting the kind of initializing kind of the ball movement. Let's go ahead and open that up in our playground and just kind of see if it works as expected. And it normally takes a few moments to load. Okay, so it looks like our code got generated. So here is what it looks like. And the ball isn't moving, but we do have the interactions with our paddles, which is cool. So I think this is like a good starting point. For me, what I think I would do now is go ahead and download the project locally, install the dependencies and run it, now that we know that the fundamentals are kind of in place. And then we can use Co-Pilot to just wire up the last bits of interactivity. So I'm going to go ahead and just download the selection. And again, this will just take a few more minutes. So our code has been downloaded. So I'm going to go ahead and just pop open my terminal, navigate to the new directory, and then install the dependencies and then run the development server. This will take another couple of minutes, depending on how fast your connection is, and then I'll see you back when it's been installed. Okay, so it looks like our code has been installed, and so let's go ahead and open it. Great, and we can see that it's kind of working a little bit. We've got the ball that's moving ever so slightly, and then we've got our paddles that move as well. So I'm going to go ahead and open up VS Code, and then we're just going to wire up the last bits of interactivity. Open up the browser here as well. Great stuff. And so the first thing I'm going to go ahead and do is just remove the instructions, because I don't think definitely don't need them anymore. Let's refresh. Great stuff. And then after that, I'm going to ensure that the paddles can't go beyond the screen, kind of like both at the top and at the bottom. And we'll do that for both paddles. So let's see. So we're going to need to check here. So the set paddle position, if the position is greater than, less than 0, then do nothing. And then we also want to do that for this one as well. And then here, if the position is greater than height of the screen or height of the game board, then also do nothing. Cool. So let's create a ref for our game wrapper. So we use ref. Great. And then we'll go down to here. And then we use game wrapper ref. Great stuff. And so in here, I don't think we need the ref actually at this point, but if paddle A position is less than or equal to 0, then just return nothing. Great. And let's see if this works. So I'm going to refresh and go up, and you can see, yeah, it hits the top, which is great. And I'm going to do the same for here as well. And we can remove this comment. If paddle B is less than or equal to 0, return. And while I really like Co-Pilot, it helps me quite nicely more quickly write the code that I want. It's always worth reviewing when it's written, because sometimes it can kind of get through some really annoying little bugs. Okay, so what I'm going to do here is actually create a helper method to get the bounding box of a ref. So get bounding. Cool, and I'll change this to lref. And so this is just like a nice little helper method so that I can quickly get the dimensions for an element instead of having to do this every single time I want it. Great stuff. And actually, I'll just return this instead. Cool. And at the top, we'll do game wrapper. Actually, we'll do top. Actually, we just need the bottom. So we'll just get bottom. And then here now, let's see if Co-Pilot can do this for us. If paddle A position is greater than the bottom, then return. Cool. Does this work? Let's go ahead. It doesn't quite work, and I wonder why that is. So paddle A position, is it because? Yeah, that's why, because the position is based on the top. So we actually need to add a ref for our paddle elements now. So let's do paddle ref, and then I'll go down to here and then do ref, paddle A ref, and we'll also add a paddle B ref as well. Cool. And so I'll go ahead and duplicate this and just swap it out for B. Nice. And then so at this point, we're going to want to go and get paddle B ref, paddle A ref. Actually, we'll do we'll top, bottom, paddle A bottom, bottom. Cool. Great stuff. And then we'll do the same here, but for paddle B ref. And we'll do the check. If paddle B bottom is greater than bottom, then return. So let's try that one more time. Great stuff, that works, and this works. Awesome. So let's speed up the ball a little bit, because right now it's super slow. So I'm just going to add a little constant up here called ball speed, and we'll call it 5. We can tweak that if we want. And then when we update the ball, what we'll do is do ball speed and then times by the direction. And because this is either going to be 1 or -1, it will just flip the speed if the ball is going in the other direction. Cool. Okay, this is a bit faster. Do we make any contact with it? Okay, we're not going to find out just yet. So let's now go ahead and add the box around our game so that the ball will bounce off of it. So we're going to need to add a handle collision function. And this happens every time the game runs. So let's see, where's this interval position? Great stuff. And I'm not going to worry about Copilot just yet. So in this set interval, update pool position. Great. So let's do handle collision. And we're going to call it new position. And this is actually going to return some updated positions. Because what's going to happen is if there is a collision, then we're going to want to return some new data. So we're just going to change this to updated position. Great. And we'll give it a singular. Keep it consistent. Cool. So now we've got this handle collision is if the ball is hit the top or bottom of the screen, reverse to the y direction. Great stuff. So now we're going to do next position. Ooh. Cool. And then we're just going to return next position here if everything is fine. So now we need to see if the ball is at the top. So we're going to need to get the ball position here. And so where are we? Cool. If ball position dot y is greater than or less than equal to 0, and actually, yeah, that's it pretty much. We're going to want to go ahead and set the ball direction and change it to y, and then return. We're actually going to change the position, so we're going to do next position, and then it's going to be a ball position dot y plus ball speed, and then we're just going to do plus times 1. Actually, we don't even need that. Okay, something's gone wrong here. Oh, I think there's clearly something up with this function. Hey, there we are. Cool. Okay, we're going to need to do the same for the bottom as well. So now we're actually going to need to do the same thing we've done for our paddle, but with the ball. So we do ball ref, because we need to get the bottom of the ball. And where is our ball? Over here. Great. Ball ref. Nice. And now in here, let's get the ball bottom. We're not interested in all of this stuff. Okay, so if ball bottom is greater than or equal to the bottom of the game board, then we'll basically just do the opposite here. So you set ball direction -1, and then we'll just do ball position minus ball speed. Yeah, that looks good. Let's try that. Great, that works. Okay, so the next thing we need to do is now add the score element to the game. So we've already got the scorecard here for player A and player B. So now if the ball goes beyond the barriers, then we'll want to reset the position of the ball and then also increment the score counter. So let's add another function called handle goal. And again, it's going to take a next position. And let's go add that in and we'll tweak it if we need to. So inside of update ball position, we're going to add a new one. And this isn't going to be like the best code. I'm not a game developer, so I'm sure there are certainly things I'm doing that aren't best practices, but we're just concerned with getting the game working. So let's say updated position. Great. So now we've got the updated position here from the handle collision. We're also going to do another function called handle goal, and that's also going to update the position if there's been a goal. So ball left here, and then the left of the game wrapper. Now, if ball left is less than the left game wrapper, then we're going to actually just increment the score for B, and then we'll reset the position of the ball. And I believe, is this it? 462, 278, what's the starting position? Okay, I'm actually going to just add this up here. So starting position for the ball. Just because I'm not a big fan of magic strings like this. Great. Cool. And then where it is here. And on top of that, actually, no, we don't want to return that. We want to set the position of that. Actually, no, that is right. Cool. And then we're also going to want to flip the position of the horizontal direction of the ball so that it's now facing towards the person who just scored. Okay. Change that to -1. Okay, let's try this and see what happens. Oh, and there's something wrong going here. Ball position X. What have I done wrong? So starting position here. Ah, that's why, because I didn't actually add this here to either. Great stuff. And then updated position 2 is not defined. That's because, there we are. And then updated position 2 is not defined. Okay, great stuff. And do we get a goal? Nice. To the other team. Cool, and that works as well. And so finally, we need to add the collision detection for the paddles and the ball. And then once we've done that, the game is done. So I'm going to go ahead and make a helper function here called have collided. And this takes two elements, two refs, and we get their bounding client recs of them. Actually, let's do a ref and call it L1 and L2. And these are going to be like element refs that we're passing through. So let's go, should be L1 dot current. And then actually no, because our helper function handles that already for us. So this is perfect. Oh, almost perfect. Now it's perfect. Okay. So back down here, what we're going to want to do is to check, see if the ball and the first paddle is colliding. So if we go and do if have collided, ball ref and paddle A, great. That's sped things up a little bit. Then we go change the ball direction of the horizontal direction, and then we'll return the new speed. And now let's go ahead and do with paddle B as well. Okay, and let's just test that this works. So now it's starting towards paddle B. Does it flip the direction? Yes, it does. Woo! Okay, now we're cooking. Now it's going a little bit slow, so I might bump up the speed of the ball a little bit. But does this work? Please say it works. Yes. Okay, amazing. Let's make this a bit more difficult for myself. Let's change the ball speed to 10. Okay, this might be a little bit too hard. Cool, no, I've got it. Okay. And so we could probably make this a bit more complicated, by adding some advanced physics, depending, the ball angle changes depending on where on the paddle you've hit it. But you can see that the score increments fine as well. So that kind of wraps up our video for today. I hope you've had fun following along with our Pong game and that you've learned a little bit about some of the cool new features that Anima's releasing. On top of that, hopefully you've learned how using some AI tools can help speed up your workflow a little bit as well. I use many of these tools very regularly and I feel like it makes me a speedier developer. And yeah, I hope you've enjoyed the video and, share any cool things that you've cooked up using Anima or any other tools.